The electrical supply system and the devices we connect to it are carefully designed with safety in mind. When used appropriately, these devices are safe. Nevertheless, there is a need for all members of staff to take care when using electrical devices and to report faults when they see them. In this short presentation, we look at the electrical supply system in the hospital and how devices connect to it. We'll then look at two particular hazards that can arise from the misuse of the system or damage to devices and their cables. Finally, we look at the role that all staff play in ensuring that the system remains safe for themselves, their colleagues, patients and their visitors. In this first 3-minute section, we're going to explain what electricity is, see where it comes from, and look at how it flows from the generating station all the way through to the hospital and the devices that we use. Electricity is the flow of electrons, and in the generating stations, engineers put big metal plates in the ground and they connect these up to the wiring system. They then use electrical pumps called generators to pump electrons out of the mass of the earth up into the wires which connect to our homes and hospital. Just as water that's pumped uphill wants to flow back down again, electrons that are pumped up into the wiring system also want to flow back down to ground. And so we provide a second wire and a second path for the electrons to flow back to where they came from. Now let's look at how the hospital connects to this electrical supply system. Electricity flows into and from the hospital through large metal cables. It is this flow of electricity that makes devices work within the hospital, that allows us to move things, to heat, to light, and to make all the electronics work. The flow of electricity is referred to as the electrical current. Within the hospital, the two wires that carry the electricity are referred to as the live and neutral, and it's important to remember that both carry electrical current. We've already seen that electricity flows through metal wires, but electricity will also flow through most fluids and the human body. Materials that allow electricity to flow through them are called conductors. Some materials don't allow electricity to flow through them, like rubber, plastic, glass, or dry wood, and these are referred to as insulators. So remember, conductors allow electricity to flow through them, and insulators block the flow of electricity. Within the hospital, the electricity is distributed through the live and neutral wires which are in the walls and run throughout the building. The live and neutral wires connect to the 3-pin socket outlets that we're all familiar with. So when you plug a device into one of these sockets, you are connecting the electricity all the way from the power station, through the building, out through the mains cable into the device that we're going to use. For the rest of this presentation, we're going to focus on the mains cable and its connection to the device. So let's quickly look at what's inside the mains cable and see how it works. The electricity is carried to and from the device through two metal wires which are inside the cable. These conducting copper wires are insulated by plastic coatings to prevent them from touching each other. These wires that carry the current are coloured brown and blue. They are then further insulated with an outer layer of plastic, usually white or black, which adds an extra layer of insulation and also mechanical strength. The third yellow and green wire in the mains cable is the earth wire, and it's there to catch any electrical current that goes astray within the device and carry it safely away. That's the end of the first section, so let's summarise the key points covered so far. We've seen that electricity is the flow of electrons, that these electrons come from the ground and are trying to get back to the ground. Materials that allow electricity to flow are called conductors, like metals and fluids, and materials that block the flow of electricity are called insulators. Electricity flows through sockets and cables through the copper wires at their centre. These wires are insulated with plastic to prevent them from touching each other, and also to prevent us from coming in contact with the current carrying conductor, the copper wire. In section 2, we're going to look at two hazards that arise from the use of electricity. The first is electric shock. If for any reason you come in contact with the live or neutral directly, then the electricity can flow down through you to ground, because remember, the electricity is trying to get back to ground. So if this happens, the electricity will happily flow down through you and you will get an electric shock. Electricity flowing through the body stimulates nerves and muscles. Depending on the circumstances that give rise to the shock, a shock can feel like an uncomfortable tingle or painful stimulus. In the extreme, it can cause internal or external burns and may result in respiratory or cardiac arrest. The second hazard we need to look at are fires caused by the electrical supply system overheating. Worldwide, more people are injured every year from electrical fires than they are from electric shock. If a mains cable gets damaged, then the insulation within the mains cable that prevents the live and neutral from touching might be damaged also, and that can result in a sudden rush of current directly from the live to the neutral. This high current can cause the cable to overheat and may cause the cable to go on fire. The socket outlets on the walls are designed to carry a certain amount of current safely. However, if people use adapters, extension leads and plug boards to plug many different devices into one socket outlet, this can result in overheating of the socket, the plug or the wiring in the walls. So the use of adapters and plug boards should be avoided. But where the needs of the service require them to be used, they should be supplied, fitted and tested by either TSD or MPBE. In this section we've looked at two hazards, electric shock and fire. In the next section we look at how we can prevent these from occurring. The fuse boards and circuit breakers used throughout the hospital are designed to trip out or turn off the electrical supply if the electricity starts to go astray. This prevents fire and shock. Also, the medical devices used throughout the hospital are designed and built to stringent safety standards, and they're regularly checked. Together, these ensure that the environment in which everybody works is electrically safe, and thankfully there are very few adverse incidents associated with electricity in the hospital. We know that in everyday use, devices and cables are subject to wear and tear, and damage can occur. So all staff members have a role in identifying and reporting potential hazards. The key message from this presentation is to take care with mains cables, and if you find a damaged mains cable, please report it. With the ever-increasing number of devices used at the bedside, there is a need for careful management of their mains cables so that they don't get caught and damaged in beds, chairs and hoists. If mobile equipment is moved before it is plugged out from the socket, this can put strain on the mains cable. Here are some examples of damaged mains leads that have been reported. In this picture we see a broken plug that's held together with sticky tape. Here we can see another plug which has been dropped and the earth safety pin has shattered off. Here you can see a fracture of the outer insulation exposing the live, neutral and earth wires, probably due to repeated strain on the cable. Here you can see that the main wire has been pulled out of the plug, exposing the live, neutral and earth wires. All of these should be reported immediately to either Technical Services Department or the Medical Physics and Bioengineering Department. Here are some more examples of wear and tear on mains leads. Let's focus on this one in the bottom right hand corner. What you can see here is the live, neutral and earth wires inside the outer insulation of the mains lead. The outer insulation has been damaged, exposing these wires. If you can see these coloured wires, then the first layer of protection has failed. You should report this immediately and change the device as soon as possible. If, however, the mains cable is damaged in such a way that you can see the copper wire, then you are in real danger. Remember, this copper wire is what carries the electric current. If you come in contact with this copper wire, you are likely to receive a severe electric shock. You should disconnect the device if it is safe to do so and report this immediately. Anywhere where the insulation is damaged and it's possible for you or others to come in contact with the copper wires, you should report this immediately. Also report any sockets or plugs that feel hot to the touch. This could be a sign that something is wrong. In the hospital, we often use electrical devices close to fluids. Remember, electricity will flow through water and saline. Take care with the positioning of fluid bags so that occasional spills won't fall on electrical equipment. And to protect yourself, never plug or unplug items with wet hands.
Well, if they've just gotten a tingle and they're feeling otherwise okay and they don't have palpitations and they don't have pain or anything like that, they're actually fairly okay to do nothing. Coming to the emergency department for a checkup is possibly wise. An ECG to make sure they aren't having some sort of odd looking rhythm. But the likelihood of that happening if they've just had a tingle and they haven't been rendered unconscious is exceedingly rare. So personally, I wouldn't go and see anybody. switch off the wall. Be safe yourself. You do not want to be a victim as well as the person on the ground. I'm assuming they're unconscious and they can't help themselves. So if you can't switch off or don't know where the switch is, then you could use a non-conducting piece of equipment. And there aren't many around, but a wooden walking stick is present in most wards in this hospital at this stage, either to pull away the cable or to pull the person away from the point of contact. And then it's into basic life support after that. If they're unresponsive, you really need to get on an AED as soon as you can, because the worst case scenario here is they're in ventricular fibrillation. And the only thing that will really work for that is defibrillation. There are defibs all over the hospital. I'm not quite sure how many there are, but there's a lot of them. And that's what you need to get on, analyse, and deal through standard life support procedures thereafter.
In this presentation, we've looked at the electrical supply and devices, discussed the fire and shock hazards, and identified how staff can contribute to ensuring the electrical safety of the hospital. A poster summarising this presentation will be posted on the notice board in your unit. This highlights the importance of reporting any damaged cables you find. It also includes 10 bullet points on how to prevent electrical hazards from arising. And finally, it gives information on who to contact if you need to report any damaged cables or if you just have some questions about electrical safety. Thanks for your attention.